Hello students. In the last session we have studied about the flip-flops. In the flip-flops are where they can used in the computer systems. Where they can use the computer system in the shift registers. How the flip-flop is using and what will be getting that output. How can we use this one? Can we see in these sessions? Yes, they can used in the shift registers. Shift registers means what? Can we see that one? Shift register is a sequential logic devices. Sequential logic devices means a sequential circuit can be called it as a combinational circuit. Can we call it as a combinational circuits? Combinational circuits. That is called it as a sequential logic devices made up of the flip-flop. Flip-flop means what? It is a sequential device. You have already knew about this. That allows the parallel or a series. How the data is moving in the serial in the parallel conditions means that if you give the data, it is how it is moving. Can we see it in this sessions? Right. Next is a I'm going to explain about the common task of the shift registers, serial and the parallel data conversions, and UART, an example of that one, time delay and ring counter, twisted ring counter, Johnson counter, and the memory devices. This is a counter, it is there for your syllabus. Yes, next is a characteristics of the shift registers. Number of bits. You have already knew about the bits. 2 bit and 1 bit in the gates, and gate, nor gate you have studied. Right. In that session you have studied the 4 bits means uh, 2 inputs and single bit for two inputs, and the 4 bit for the 4 inputs, 8 bit for the means input is like a 4-bit devices. For example, I'm going to give that one. It is a and b. It is a and b. It is a 4-bit, like a not gate. It is a 2-bit, a and a bar, and 4-bit it is a like the 8-bit, a b c d. Like that can be used it 8-bit data and 4-bit data can be know that one. Loading of the serial and the parallel, asynchronous and the synchronous counters. Right. Next, common modes of operations. Common modes of operations means parallel load, shift right, serial load, shift left, serial load, and the hold and the clear. First one, parallel load means if you apply for the input, it will how comes the output, can we see that one. Shift right serial load, shift left serial load, hold means to stop, clear means reset. These are the instruction of the common modes of operations. Recirculating the non-recirculating. Circulating and the non-circulating can be used. Serial parallel data conversions. Serial parallel data conversion can be called it as a serial to parallel. How can we convert that one? Serial parallel data conversions. Shift registers. What is the meaning of shift? Shift means I'm going to give the some food to you. I told you, give into your neighbor. Yes, that time I want to give a some dish to neighbors. I told to my friend, yeah, just take this dish and give it to the neighbor. I will tell that. What she will do that one? She take the food and give it to them. Like like a chain system. I want to give this one to other one, it will take that one. If that like that one, she used it. Otherwise, she will shift into the other ones. Correct? That is a way. Shift register can be used to convert the from serial to parallel or the reverse from parallel to serial. Yes, this is the serial in, serial out. Means this is the 10 10 11 11. This is the serial out. First, what will go that one? 1 will go that one. That time 0 1 0 1 0 1 1 only left. Est ಉಳಿಯೋದು ಯಾವುದು? ಇಲ್ಲಿ 0 ಬರ್ತದೆ ಮತ್ತೆ ಅದು ನಂಬರ್ ಶಿಫ್ಟ್ ಆಗ್ತದೆ. ಶಿಫ್ಟ್ ಟು ದ ಕಂಪ್ಯೂಟರ್ಸ್ ಆರ್ ಎಲ್ ಇ ಡಿಸ್ ಎನಿ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಡಿವೈಸಸ್. ನೆಕ್ಸ್ಟ್ ದಿಸ್ ವಿಲ್ ಶಿಫ್ಟ್, what will come? 0 0 1 0 1 0 1 that comes. Like that one, it is a serial in, serial out. Yes. Next is one by one, serial in, serial out. Next is a serial in, parallel out. Parallel out is a different one. How can we use that one? If we give in this direction, it will goes. How it works means one will go first, then what will come for that? This will come again, it will go like that one. It is a circulate for that one. Yes, that is a serial in, parallel out. Next, serial in, serial out. Serial in, parallel in enters into that one, serial out. Parallelly the words will come and serial out. Yes. Next, parallel out, parallel in, parallel out will come that. This is the way of numbers will come and it will moves in the computer devices. Yes, four directions are there. Correct. In the four direction, the datas are moving. Right. The four directions are there: serial in, serial out, parallel in, parallel out, serial in, parallel out. Whichever the directions the data will come, it will enters into the different configurations. Right? Can we see that one? Serial load shift register. This is the symbol of that one, can be expressed. Serial load shift registers. Load means if you give the data is here, it is a load. Shifting the datas. Yes, the shifting the datas. Yes, clock is used for that one. In the serial load shift registers can be used. It is in the serial in, serial out can be expressed. Yes, serial in and the serial out can be expressed in this diagram. In this diagram, I'm going to express this one. Yes, I'm going to take this one. Serial in, serial out. I'm going to write this equations, draw the circuit for that one. I'm going to in the simple way we can call it as a SISO, serial in, serial out. This is the main importance of that. We are calling it as a SISO. It is a serial in, serial out shift register. Yes, I'm going to just draw the circuit of that one. You have to see this one. How does this circuit works? Right. This is the using the D flip flop. I'm going to use the D flip flop. It is a D1. This is the output is Q2. Yes, Q2. I'm going to write this D2. I'm going to write this one is a D2. It is an input. This is a clock. I'm going to give that one. Three flip flops I'm going to use D1, Q1, D3, Q3. This is the clock pulse I'm going to give. This is the clock. This is the clock I'm going to give, and that this is the input is moving like that one. It is a serial load means if you want to give this values in this way, the moving from serial in and the serial out can be expressed. Serial in and the serial out can be expressed in the representation if your the values are moving like that one. Movies are, it is the input, if we can give it, it is the output. This is the serial in and the serial out, right? This is the condition for that one. This is the condition I am going to express this one. Yes. Now I want to give this one. First clock. Apply the clock is here. This is the clock. This is the D of the input. This is the input. First condition of this one. First condition of this one. I am going to express this one is a input, is a single input. 0 and the 0 will come. Q2, Q1 and Q0. First clock is a 0. Clock is 0. When the reset, all three are 0 in the state. All three are 0 in the state. Right. In the second clock, I am going to give that one. I am going to give that one in the second clock is a 0. 0 will come that one. Here also I am going to give the 0. I am just minimize this one. Yes, this is the clock and this is the input. I am going to give that one. First I am going to express about this one. This is the clock is 0 in the first state. I am going to write the clock is 0. Clock is 0. The clock is 0. The input is 0. The Q3, Q2 and Q1 is also a reset. Reset means all are zeros. Then this is a 0. This is the input for that one. Clock 1. It is in the 1 high. It is a 0, 0, 0. This moves the values. This is the moves the values from 1. 1 is the input, give that one. That it comes 1, 0, 0 in the, this is the first clock, second clock, third clock. This serial is enters, I don't know this one. This is the continuous 110. The fourth clock is 1 110. The fourth clock is comes 0 1 1 0 1 1. This one is moves here, this one is moves here, this one is moves to here. This is the fifth clock will come. It will get the output. Then 0 0 1 will come. This will go to the any devices like that one 0 0 0 in the sixth clock. ಅರ್ಥ ಆಗಲಿಲ್ಲ ಅಂತಂದರೆ ಫಸ್ಟಿಗೆ 0 ಕ್ಲಾಕ್ ಕೊಟ್ಟಿರ್ತೀವಿ, 0 ಇರ್ತದೆ, ಇದು ರೀಸೆಟ್ ಆಗಿ 0ನೇ ಇರ್ತದೆ. ಆಮೇಲೆ ಇಲ್ಲಿ ಕ್ಲಾಕ್ 1 ಅಂತ ಕೊಡ್ತೀವಿ, ಫಸ್ಟ್ ಕ್ಲಾಕಿಗೆ ಶುರು ಆಗ್ತದೆ. ಈ 0 0 ಕೊಟ್ಟಾಗ 0ನೇ ಬರ್ತದೆ. ಯಾವಾಗ ನಾನು 1 ಅಂತ ಇನ್ಪುಟ್ ಕೊಡ್ತೀನೋ 1 ಎಂಟರ್ ಆಗುತ್ತೆ. ದಿಸ್ 1 ಈಸ್ ಎಂಟರ್ ಟು ಹಿಯರ್. ದೆನ್ ಇಟ್ ಈಸ್ ಅ 0 ಆ್ಯಂಡ್ 0. ಇದು ಮೂವ್ ಆದ್ರೂ ಇಲ್ಲಿ ಏನಾಗ್ತದೆ, 1ನೇ ಬರ್ತದೆ. ಇದು ಮೂವ್ ಆಗೋದೇ ಇಲ್ಲ, ಯಾವುದು ಇನ್ಪುಟ್ನ ಕೊಟ್ಟೇ ಇಲ್ಲ ಅಂದಮೇಲೆ 0ನೇ ಮೂವ್ ಆಗ್ತದೆ. ಈ ಝೀರೋ ಮೂವ್ ಆದ್ರೂ ಈಗ ನೆಕ್ಸ್ಟ್ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ 1 1 ಬರ್ತದೆ. ಈ ಝೀರೋ ಎಂಟರ್ ಇನ್ ಟು ದ ಕಂಪ್ಯೂಟರ್. ಝೀರೋ ಈಸ್ ನಾಟ್ ಅ ವ್ಯಾಲ್ಯೂ. ದಟ್ ಟೈಮ್ ಈ ಈ 1 ಮತ್ತು 1ಗಳು ಮೂವ್ ಆಗ್ತವೆ ಮುಂದ್ಗಡೆ. ಆವಾಗ ಹಿಂದ್ಗಡೆ ಏನಾಗುತ್ತೆ, ಝೀರೋ ಬರ್ತದೆ. ದೆನ್ ದಿಸ್ ಒನ್ ಈಸ್ ಮೂವ್ ಹಿಯರ್, ಝೀರೋ ಝೀರೋ ವಿಲ್ ಕಮ್. ದಿಸ್ ಒನ್ ಈಸ್ ಮೂವ್ಸ್ ಎಂಟರ್ ಇನ್ ಟು ದ ಕಂಪ್ಯೂಟರ್, ಇಟ್ ಈಸ್ ಅ ಝೀರೋ ಝೀರೋ ವಿಲ್ ಕಮ್. ಅಗೇನ್ ಇಫ್ ಯು ವಾಂಟ್ ಟು ಗಿವ್ ದ ಸೈಕಲ್ ಅಗೇನ್ ಮತ್ತೆ ಒಂದು ಕೊಟ್ಟರೆ ಅವಾಗ ಈ ಸೈಕಲ್ ಕಂಟಿನ್ಯೂ ಆಗುತ್ತೆ. ದಟ್ ಈಸ್ ದ ಸೀರಿಯಲ್ ಇನ್ ಸೀರಿಯಲ್ ಔಟ್. ಸೀರಿಯಲ್ ಇನ್ ಸೀರಿಯಲ್ ಔಟನ್ನು ನಾನು ಹೆಂಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ಬೋದು ಅಂತಂದರೆ, ದಿಸ್ ಇಸ್ ದ 1 0 1 0 ಅಂತ ಒಂದು 4 ನಂಬರ್ ಬಂದಿರ್ತದೆ. 4 ಬಂದಿದ್ದು ಫಸ್ಟಿಗೆ ಯಾವ್ದು ಹೋಗುತ್ತೆ, ಝೀರೋ ಹೋಗುತ್ತೆ. ಅವಾಗ ಏನಾಗ್ತದೆ, ನೆಕ್ಸ್ಟ್ ಶಿಫ್ಟ್ ರಿಜಿಸ್ಟರ್ಸ್ ಏನಾಗ್ತದೆ, ಇದು ಝೀರೋ ಬಂದರೆ ಇಲ್ಲಿ 1 ಬರ್ತದೆ, ಝೀರೋ ಬರ್ತದೆ, 1 ಬರ್ತದೆ, ಇಲ್ಲಿ ಝೀರೋ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ದಿಸ್ 1 ಈಸ್ ಎಂಟರ್ ಟು ಹಿಯರ್. ವಾಟ್ ಈಸ್ ದ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್? 1 is enters to here, 0 is here, 1 is here, 0 and 0. This 0 is enters to here. Fourth ಏನಾಗುತ್ತೆ, 1 ಇಲ್ಲಿ ಬರ್ತದೆ, 0 0 0 ಆಗ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ 1 is enters into the computers, 0 0 0 0. Like this way the shift register in the serial in and the serial out can be expressed. Next one is the shift registers of serial in, parallel out. Serial in and parallel out can be expressed by this circuit can be expressed. This is the data. It is a serially the inputs are coming, the parallel the outputs are there. Parallel the outputs are there. Yes. This is also call it as the name of this is serial in, parallel out. Serial in, parallel out. First one, I am going to give the clock pulses. I am give a clock pulses. Yes, first input is clock input. Outputs Q2, Q1, Q3. Here it is a ABCD are the inputs. ABCD are the inputs. You can take that one. I'm going to express about the ABCD. Q3, Q2, Q1. Can we take it? Yes, can we take it like that also? Yes, I'm going to give the this ABCD is a output. ABCD is the output. I'm just this one, remove that one. I'm going to give that one. Yes, ABCD is the output. This is the output, right? Then I want to give the clock. Clock is 0 first. Initially clock is 0 0. Input is 0 0. The all are zeros. The all outputs are outputs are zeros. Next I am going to give that one. First clock is 0. Then I will give the first clock. First clock I want to give that one. First clock is 1. That is the input is 0. That is a 0 0 0 will come. Yes. Next I am going to give that one. In the second clock. In the second clock I am going to give the high input. That it comes 1 0 0 0 will come. 1 0 0 0 will come that one. Then third clock 1 will give that one. The next clock 1 will give. One more 1 will give that. That time 1, 1, 0, 0. Fourth clock, fourth clock, 1 will give that. I am giving 1, 1, 1, 0 will come. Fifth clock, I am going to give the 1. That is the output 1, 1, 1, 1 will come. Clock I am giving. Next clock, sixth clock again, I am giving 0. That comes in the shift to other one. 0, 1, 1, 1. Next clock, I am going to give a 1. Seventh clock, 1 coding. That will shift here. 1, 0, 1, 1. Eighth clock, I am giving the zeros. 0, 1, 0, 1 will come that. The continuously, if you are giving the input to that one, it will continue like that one. It will continue till the end of that one. This is the way of that one. Serial of the data, whatever you are giving, it will continue for that one. It will continue in the next datas. Like this is the way of the serial in and the parallel out in the circuits. Yes, these are the circuits can be expressed in that one. It is in the serial in and the serial out can be used. Serial in and the serial out in that one. Time duration of that one, n minus 1 into t can be used. 2n minus 1 into time duration. It is a 4-bit data. Clock is 2 milliseconds. The answer will be the 14 clock pulses are there. 14 clock pulses will come. 4-bit in the 2 milliseconds time will you give that one. Whatever you are giving that one, you have to check that one. You will get the output for that one. Yes, this is not the D flip-flop clock input weird. When the parallel clear, the outputs can be activated with the low or disable with the high present state of that one. First I am going to express this one. I'm going to express this one. Clock pulses, I'm going to express this one. 1010 is a input. Input is a 1010 input. You will get it in the clock is high or the 0101 will come in the next. I'm going to give the clock pulses is high and low. High and low can be used like that one. The clock is high, in the input is high, the already it is given, it is a high. Yes, yes, this is the high. This is a D output. This is the clock pulses. Clock pulses if you want to give that one. This is the output. Q3 is 0. Q3 is 0. I'm going to draw that one. This is a Q3. Q3 is 0. Q2 is high. Then it is don't know low. Q3 is Q1 is, this is the low, then it is a high. This is the way that one. If you are giving the 1010 1010, first shift this 0 to here, then 101, then it will shift here 0010. This will shift here, shift to the computers, then 0001. The last function is 0000. We'll get it in the fifth cycle. This is the 4-bit data I am going to express in this inputs. Yes, These are the clock pulses can be used in the serial in, serial out. In the serial in, parallel out can be used in the 2n. Whatever the n of that one into t can be used that one. Yes, this is the serial in and the parallel out of the counters can be used. Yes, this is the parallel outputs. These are the parallel outputs. A, B, C, D. I have told you. These are the inputs here. Data, clock and the clear. Yes. Next is the clear the input active 0 and the deactivated 1. Clock inputs is a positive edge triggered. ಯಾವಾಗ ನಾವು ಕ್ಲಾಕನ್ನು 1 ಅಂತ ಕೊಡ್ತೀವೋ ಆವಾಗ ಟ್ರಿಗರ್ ಆಗಿ ಪಾಸಿಟಿವ್ ಎಡ್ಜ್ ಟ್ರಿಗರ್ ಆಗ್ತದೆ. ಓಕೆ. Next is the data 1. Clock pulses are first one 0. Next I am going to give the data 1 in the positive 1 0 0 0. Next that 1 is shifting. 1 will give that one. ಫಸ್ಟ್ಗೆ 1 ಡಾಟಾ ಕೊಡ್ತೀನಿ ನಾನು 1 ಅಂತ 1 ಕೊಟ್ಟಿದ್ದು ಉಳ್ಕಿದ್ದಷ್ಟು 0 0 ಆಗ್ತವೆ. ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಕ್ಲಾಕಿಗೆ 1 ಕೊಡ್ತೀನಿ 1 1 0 0 ಆಗ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಥರ್ಡ್ ಫಸ್ಟ್ 0 0 ಇರ್ತದೆ. ನೆಕ್ಸ್ಟ್ 1 ಕೊಡ್ತಾರೆ. ಅದರ ನೆಕ್ಸ್ಟ್ 1 ಕೊಟ್ಟಿದ್ದು 1 0 0 ಆಗ್ತದೆ. ಆಮೇಲೆ ಕ್ಲಾಕ್ ಪಲ್ಸ್ 4ಗೆ 0 ಕೊಡ್ತೀನಿ, ಡಾಟಾ 0 ಕೊಡ್ಲಿಕತ್ತೀನಿ, ಡಾಟಾ 0 ಕೊಡ್ತೀನಿ ಮತ್ತು 0 0 1 1 ಆಗ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಡಾಟಾ 0 ಕೊಡ್ತೀನಿ, ಅದು 0 0 0 1 ಆಗ್ತದೆ. ಮತ್ತು ಡಾಟಾ 1 ಕೊಡ್ತೀನಿ, ಇಲ್ಲಿ 1 ಆಗ್ತದೆ, 0 0 0 ಬರ್ತದೆ. ನಾನು ಯಾವ ಡಾಟಾನ ಕೊಡ್ತೀನಿ 1 ಕೊಡ್ತೀನಾ ಅಥವಾ 0 ಕೊಡ್ತೀನೋ ಅನ್ನೋದ್ರ ಮೇಲೆ ನಮ್ಮದು ಔಟ್ಪುಟ್ ಡಿಸೈಡ್ ಆಗಿರ್ತದೆ. ದ ಹೋಲ್ ಕಾನ್ಸೆಪ್ಟ್ ಈಸ್ ಡಿಸೈಡ್ಸ್ ಆನ್ ದ್ಯಾಟ್ ಒನ್. ಎಸ್, ವಿಚ್ ಎವರ್ ದ ಗಿವಿಂಗ್ ದ data. That is the whole concept of that one can be see that one. This is the serial in and serial out. In the equations can be serial in and the parallel out can be used for that one in this sessions. Okay, in the next session I am going to explain about the parallel circuit. How does this works? Okay, thank you. Please watch our videos regularly. Thank you.